All right, thank you for having me. So I'll just let you know when to advance the slide.
Yes, please.
Okay. So using architecture as an investigative data set in archaeology allows the researcher to move beyond the scope of the individual household and attempt to tease out larger patterns of behavior across a landscape. Spatial data allows analyses of patterns, costs, visibility, distributions, and land use. And when these analyses are coupled with population data and an understanding of social, political, and environmental trends through time, we can model and quantify choice by prehistoric agents. In this paper, we use the placement of public architecture on the landscape in relation to contemporaneous habitation sites in Mesa Verde National Park to assess accessibility, visibility, and changes in these characteristics from AD 600 through 1280. Next slide, please. Okay, so while this paper focuses on habitation and public architecture in Mesa Verde proper, it is part of the larger Village Ecodynamics Project, or VEP, which focuses on 2 study areas in the Four Corners region. Mesa Verde National Park is outlined in the northern study area here. Next slide. Karen.
Hi, can you hear me?
Yeah, I can hear you now.
I'm sorry. I had a technical problem.
Oh,
Hi. So where would you like me to be? Where would you like to be right now?
One more slide ahead, please.
Okay. Excuse me, I'm so sorry.
That's all right. Okay. This is a close-up of the Mesa Verde landform with the extent of the park. We limit the sites used in this project to the borders of the park, and this is for a few reasons. The northern VEP study area extends beyond these borders and includes site data to the north and east of the park off of the Mesa Verde landform. But the archaeological coverage outside of the park is not nearly as complete as the essentially 100% survey coverage assumed within the park, virtually unique for such a large area. And we don't have any information to the south and west of the park's borders. So even though the border we're using is completely arbitrary, at least it's well established. Next slide, please. There are several structures in the VEP considered public architecture, which include great kivas, reservoirs, great houses, multi-walled structures, D-shaped structures, plazas, structures with enclosing walls, oversized pit structures, and towers. For this paper, however, we are focusing on the access to great kivas, reservoirs, great houses, plazas, and towers in hopes of covering the widest range of accessibility and visibility in Mesa Verde through its occupation. We're ahead one slide now, but on the last slide, you could see pictures of relatively representative examples of each type of public feature. For this project, the height above ground for each structure is standardized. So we use 2 meters for great kivas, 2 meters for reservoirs, 7 meters for great houses, 0 meters for plazas, and 7 meters for towers. And next slide, please. This paper is an offshoot of my thesis work in which I developed a cost distance and clustering algorithm to extrapolate areas of likely intensified interaction between contemporaneous households, which I'm going to run through really quickly here with an example. What you see on the screen is all habitation sites that were occupied from AD 1225 to 1260. I ran a cost distance and clustering algorithm to group these sites based on similarity of shared land cells within a given extent. Next slide. This produced clusters of sites which represent areas of likely intensified interaction or perhaps communities. Through this process, the clustering algorithm chose exemplar points from the data set, which are the sites that best represented all other sites within the cluster based purely on similarities in travel cost with all contemporaneous households to the surrounding landscape. And I want to emphasize that only sites with a habitation component were included in this analysis, and sites recorded with a purely public component were not included. Next slide, please. An unexpected result of this analysis was that many of the exemplar sites fell within recognized community centers, and these are shown in red on the screen. Community centers are generally distinguished from other habitations by their size and typically house various types of public architecture. Next slide. As you can see by the red line in the top graphic, a community center is chosen as the exemplar on average about 20% of the time. And the yellow line represents the percent of households that are within community centers in relation to the total number of households for a time period. The relationship between these two numbers is perhaps representative of the changing degrees of social inclusion that waxed and waned through time. Within those community centers that were chosen as exemplars, we also have varying frequencies of architectural features. The stacked bar plot shows the frequency of public architecture by type within community centers that were chosen as exemplars through time. Next slide. The archaeological landscape we see today is a palimpsest of artifacts and architectural features that were used, abandoned, and sometimes reused through time. And tackling this data can feel overwhelming. Furthermore, as with most everything in archaeology, we must infer use, importance, activity, and longevity of these architectural features based on a myriad of informed assumptions. With this in mind, however, we must remember that the placement of architecture on the landscape is the direct result of a deciding agent. The production of architecture large enough to require an investment in labor and community organization, we can assume, was a planned event performed with intent. Public architecture in the Mesa Verde landscape is a physical representation of social organization and active choice by individuals to participate in community labor events to produce areas of public gathering or use. The access to this architecture by the contemporaneous population, however, is not necessarily equal among all households. The decision to place a public good in a certain space would have inherently increased accessibility to a specific subset of the population while inhibiting access to others. The ability to access public architecture on the Mesa Verde landscape is assessed in this paper through both visibility and accessibility to understand the decisions that were being made when a public good was built, how those decisions may have changed through time, and what social, economic, or political factors may have ultimately influenced this deciding agent. Next slide, please. The BEP uses a series of calibration data sets and Bayesian statistics to determine which of the 14 time periods from AD 600 through 1280 a site was most likely occupied. For this paper, we are assessing the public architecture shown on the previous slide during the period in which it was likely built and comparing accessibility to all contemporaneous households. For periods from AD 600 through 1060, we momentize the households to determine the likely population on the landscape at any given time within the period range, and then we select a random sample equal to the number of momentized households from the total households to calculate accessibility. For later periods, expected use life is as long as the period length, so momentization is not necessary. The right-hand column is the maximum cost radius in cost kilometers, which is a value that was produced out of my thesis work. The cost distance value is calculated using Tobler's hiking function, which measures the cost in time of traversing 1 meter on a 0-degree slope. When applying it to an elevation model, we can calculate the cost of traversing a variable landscape in comparison to a flat surface. This value is produced by calculating the cost distance between all pairs of habitation sites within each cluster for each time period, and then averaging the maximum values. This value is the average maximum cost distance households were traveling in each time period to interact with other households in their community. And it is used in this paper as a maximum cost radius around each public feature to limit the calculations to the landscape and households most likely interacting with that public feature. Although these values are pretty similar, when assessing them in comparison to the number of households on the landscape, we see that households are organizing themselves in a way that maintains the ability to easily interact with other households while maintaining enough arable land per household within the community boundary. And we only see huge fluctuations in this number during periods of population upheaval. Next slide, please. We measure accessibility by quantifying several factors that represent access in one way or another to produce an accessibility metric. And these include the null cost distance, the household cost distance, the household visibility, and total household. And I'll go through calculating each one of these values. Next slide, please. So again, we'll use the households from AD 1225 through 1260. And we are going to use the access to the Great House during this time period as an example. Next slide. Sorry, we're one ahead. Thank you. So what you see on the screen is the Mesa Verde landscape with all households occupied during AD 1225 to 1260. The far view Great House is shown in red. To calculate the null cost distance, we select all cells whose cost to the public feature falls within that maximum cost radius, which in this time period is 1.521 cost kilometers. Next slide, please. This leaves us all cells within that cost radius, and then we calculate the null cost distance of reaching the public feature from a random sample of those cells. So if the public feature were placed randomly within this area with no regard to the placement of its existing population or other built features, the null cost distance values and those calculated from the actual habitation sites should be equal. So the average cost distance from a random sample of cells within this radius is calculated, and this gives us the null cost distance value. Next slide. The household cost distance value is then produced by calculating the cost distance from all habitation sites within this radius to the public feature along their least cross path. Next slide. This is used to quantify the physical cost of participation and use of the public feature. So the higher the cost to reach the feature, the smaller the accessibility value. Next slide. The household visibility uses a viewshed algorithm to determine whether or not the destination architecture is visible from the household of the traveler. As I mentioned before, the height of the destination architecture varies based on its type, but we assign Great Houses a height of 7 meters, and the traveler is given a height of 1.6 meters. So the visibility analysis calculates how many of the households within this radius can see the Great House from their room block. The reasoning behind this metric is to understand the degree of social knowledge that must exist within the household to participate in the public feature. If there is no knowledge of a public feature and the feature is not visible, the household is less likely to participate. However, an increase in visibility of the public feature would make it more likely for a household to participate even if no previous knowledge of the public feature existed. So the higher the visibility value, the more accessible the public feature. Next slide. And finally, the total households is just the total number of households that fall within the maximum extent radius. Next slide, please. This process is done for each public feature in each phase to calculate access. For this paper, we produce an accessibility metric that is equal to the null cost distance divided by the average household cost distance multiplied by the percentage of households that can view the public feature. This is done in an effort to produce one number to represent access. The metric will be closer to 1 if the cost of traveling to that feature is low and the proportion of households able to see the feature is large. And the accessibility value will be closer to 0 if the travel cost is high and the visibility proportion is low. Next slide. The accessibility results for each type of public feature within a given time period were averaged to get an idea of overall access by feature through time. On the screen is the average access to great kivas, great houses, reservoirs, plazas, and towers. Most of the results are what could be expected. We see a general decline in accessibility through time as aggregation and violence increase in the region, including a sharp decrease in accessibility to great kivas, plazas, and towers in the 1100s. Great kivas are highly accessible in earlier time periods and only see a marked decline when plazas begin to be constructed. We also see that reservoirs become more accessible through time, perhaps in response to the increasing number of drought events, including a notable decrease in precipitation during the AD 1100s. Although there are only 2 great houses, it is interesting that the value remained essentially the same even though the 2 were constructed over 200 years from one another, perhaps suggesting consistency in use and intent regardless of the social climate at the time. Access to plazas generally decreases, which is likely a result of the general trend of large sites moving from mesa tops into alcove settings. Towers are also become decreasingly accessible through time, but the reasoning behind this may be a little bit more complicated. Towers are thought to originally demarcate land use, and through time and increases in violence become defensible structures. What we see in AD 1060 to 1100, the first period in which towers are built, is that they are not very visible from contemporaneous households. In fact, many towers in this period have an accessibility metric of 0, meaning there are no households on the landscape that have a direct view of the tower from their room block. However, the cost of accessing these features keeps the accessibility metric relatively high in comparison to later periods. As we move through time, however, both the visibility and cost of access increase, ultimately creating a decrease in the accessibility metric. Next slide, please. And then we can average these values through time to get a general idea of the changes in placement of public features and the shift in accessibility that occurs due to these changes. Next slide. So future studies should disaggregate the cost of access and visibility to better understand and examine how these two metrics relate to one another through time. We can also examine how the presence of public architecture affected the settlement patterns of future households, since in many cases, these public features likely functioned longer than the period in which they were built, perhaps showing that households were drawn to a certain area because of the presence of public features. We can also examine the longevity of occupation of each household and how their relationship to certain public features may have increased or decreased their duration of use, and how the length of occupation may have changed with social, political, or environmental factors. Future study could also examine higher order social communities beyond the scope of the daily interacting household and focus on the reach of public features in the social sphere. By quantifying the labor involved in producing public features and the households needed to produce them, we can map the households most likely to have been involved in the production of those public features. And next slide, that's all I got. That's it. Thank you.
Oh, thank you, Kelsey. What an interesting talk. Do we have any questions? No? I'm sorry if I missed this earlier in your talk, but why do you think that towers were most prevalent in your talk?
Towers were most what?
In your study.
Sorry, just ask the question one more time. You cut out at a second.
What?
Just ask the question one more time.
Okay, why do you think that towers were most prevalent in your study?
Why were they most trouble?
No, what? They were the largest number of public features.
Oh, the highest frequency?
Yes.
Well, I mean, towers were used, I think, for several purposes through time. So, you know, whether they were, or when they were initially built or built later, they just ended up kind of littering the landscape. And there's a smaller labor cost involved, I think, in producing a tower versus something like a great kiva or a great house. So the combination of needing them for different things, so they were built in different areas. If they were first built for demarcating land and then later as defensible structures, they would need to be placed in different areas. So there just ended up being more of them because they were a consistent structure used through time versus something like a great kiva that wasn't used after a while, or a great house that was only, you know, existing in a period or two. And then, yeah, also the amount of, you wouldn't necessarily have to have an entire community come together to put in the labor costs like you would for a larger structure.
Ah, I see. Had you considered that the visibility might be of these various public structures might have been, I don't know, extended or enhanced by fire building?
Yeah, that's definitely a possibility, especially if you think if there's some type of ritual activity occurring at these places, even if you couldn't see, you know, the structure from the ground, you would definitely be able to see something like, you know, smoke or whatever, if that was part of whatever ritual was occurring at that spot. Trying to include that in a study like this would it would be difficult just because well, it would be difficult in two ways. One, because if you say, okay, you know, if the smoke goes up in the air and you can pretty much see it from anywhere, then you have visibility no matter what. The other issue is that in the Mesa Verde landscape, because it is so variable and you have the series of canyons and mesa tops, seeing smoke wouldn't necessarily, you wouldn't necessarily be able to tell where it's coming from or how far away it might be if you're in a canyon bottom and all you can see is smoke in the sky. So, so can you really, to be able to quantify or say that is visibility to the point where somebody can say, oh, that's my, you know, that's the great kiva down the way. They must be having a, you know, a gathering. That would be difficult to actually tease out.
Yeah, that's true. So, what are your future plans for this research?
Well, with this, I think there are plenty of future studies that can be done. I think, you know, when I did this study, I created a program that basically did all the work for me and chugged out the results. So separating out the cost of traveling versus the visibility costs, and then kind of plotting those against each other and see how those relate for each structure through time would definitely be an improvement. The visibility can also be refined in the sense that I was just calculating somebody, you know, standing at their household if they could see a public feature or not. But, you know, there's a lot of movement in this landscape, so even as you're going about your daily routine, you would end up seeing these structures and running into them and having some type of social knowledge of them. So expanding the visibility to not be so, I don't know, small. Just to get a better idea of the realistic environment that these people were interacting in and living in. I think that would greatly improve it.
Yes. I know that there's, you know, you could only talk about a small portion of it today, but certainly looking at the environment and environmental constraints would probably tease out some of the answers that you're seeking. Yeah.
No, and I have a colleague, Dr. Kyle Brzezinski, is working on that. So as soon as he gets that stuff published, then hopefully we'll be able to put it together.
Oh, well, very good. Are there any other questions? Do people have any questions? Well, Kelsey and Laura, thank you very much for being with us today.
Thank you for having us.
You're very welcome. Remember, everybody, on October 1st, we have Stephen Peterson, who's going to talk about archaeology in the Nez Perce War at Yellowstone National Park, and Brunswick is going to talk about research